Good afternoon. Today we are doing CO6. I can find the least common multiple of a set of numbers. Just like we did the greatest common factor. Remember, factor buddies are when we go small. Now we're doing least common multiple. So now we're multiplying up. Lacey, why don't you take your binder and come on up here so we're not quite so distracted back there. So let's see what the definition of a multiple is. A multiple are numbers a given number can go into. Found by skip counting. So if we're looking at multiples of 2, we're going to skip by 2's. 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10. We're skipping by 2's, right? We're multiplying up by 1, by 2, by 3, by 4, by 5, by 6. So you're finding all those multiples of that number. So remembering how factors and multiples differ can be tricky. So here's a comparison to see the difference. When we talk about factors, I want you to think of the factor buddies. Factor buddies are the two numbers you multiply together to get to that number. So factors of 12 would be what? 7?
1 and 12.
1 and 12. What else? Claire? 2 and 6. Lately.
3 and 4.
3 and 4. Those are the factors, the factor buddies. So think about that when you see factors of a number, think factor buddies. Now when we talk about multiples, we want to look at multiplying up. 12 times 1, everybody together. 12 times 1?
12.
12 times 2? 12 times 3?
36.
12 times 4?
48.
12 times 5? 12 times 6?
72.
Okay. So multiples are you are multiplying up. And you go in order. 1, 2, 3, 4, 5. Those are the numbers you multiply by. Factor buddies, you go down to the factor buddies. Okay? Multiples, you multiply up. And we're going to see what it means to find the least common multiple. Do you have a question, Fiona?
Say like how many numbers you have to do for like the multiples, or do you
So that's a really good question. As we go through how to find the least common multiple, I'm going to show you how far out we should go with our multiplying. Sometimes we have to go really far out, sometimes we don't. Matthew? Okay, so you thank you, Olivia. All right, so we have different methods, just like with the group greatest common factor, we have different methods. We have different methods with our least common multiple. So for the least common multiple, sometimes I refer to it as the LCM, least common multiple. You're going to use the MCL method. So we're going to look at 6 and 10, and we're going to find the least common multiple. So the first thing we're going to do is we're going to find multiples. I like to go out 10 when I'm doing this method. So I'm going to start with 6. So 6 times 1, 6 times 2, 6 times 3, 6 times 4, 6 times 5, 6 times 6, 6 times 7, 6 times 8, 6 times 9, 6 times 10. Now I'm going to do the same thing for 10. 10 times 1, 2, 3, 4, 5, 6. Have I already hit some multiples? Yeah, so I don't need to go all the way out to 10 because I've already hit some of their multiples. I can stop myself. So now I need to find common. So this is multiples. The C is common. Which multiples do they have in common? Remember with the greatest common factor, we circled what was in common. So we're going to do the same thing with our multiples here. They both have 30 and 60. Now we need to say which one is the least. Which one is the smallest? Christian? 30. So our least common multiple is 30. Okay? So that method's pretty easy until you get really big numbers. So we have another method. I'm going to use those same small numbers of 6 and 10. Sometimes when we have small numbers like 6 and 10 and we know their multiples, we can find that least common multiple quickly by doing this method. But when we have bigger numbers or numbers that we don't know, or we have multiple numbers that we're doing, it really helps to use the table method. So let's look at how we use the table method. So we're still doing 6 and 10. So think about how we did it with our, you know what, I have prime factorization in my book. So the table method was the way that we did it over there. So let me go grab off of the wall again. So I have my examples for us. We did this with the greatest common factor. We're going to do it with the least common multiple. So this time I'm going to take this one off to bring up. So because this is what's on my board back there, I'm going to show you how this works with the 36 and the 120, and then we'll do it with the 6 and the 10. But remember, when we did the greatest common factor and we did the table method, we put our two numbers up there, and then what did we have to pull out of it? Grayson? Special kind of number that goes into them. We want to go all the way down to the what, Lucas? Primes. Well, we just find a prime. Find the prime that you can pull out of both. So I can pull a 2 out of both. 2 is a prime. Remember, 1 is not a prime. 2 is our first prime. So I always start with the 2 if they're even numbers, because I know that's an easy prime to pull out. So I have 2. So 36 divided by 2 is 18. 120 divided by 2 is 60. Now I'm going to pull another prime out. They're still even. So what prime should I pull out, Damien? 2. Another 2. So now I get 18 divided by 2 is 9. 60 divided by 2 is 30. Now what prime can I pull out, Kaylin? Or Claire? Sorry, I'm looking at Claire. 3. I can't pull a 2 out because 9 isn't an even number. 9 divided by 3 is 3. 30 divided by 3 is 10. Is there another prime that I can pull out? No. No. When we did greatest common factor, we just multiplied those 3 up. When we do least common multiple, we multiply all those numbers. So we would do 2 times 2 times 3 times 3 times 10. So remember, our numbers that we're working with are 36 and 120. What is their least common multiple? What number is it? 360. So the least common multiple of 36 and 120 is 360. Do you understand how we found it, Henry? Yeah, so instead of, we're not making noises, especially while I'm recording. Instead of having to list out multiples of 36, because I don't know about you, I don't have multiples of 36 memorized. I have multiples of 6 memorized, pretty easy. Multiples of 36, that would take me a while. Okay, I would have to either do the math in my head or use my calculator. It's not as easy. So when we have these bigger numbers, using the table method helps us find that least common multiple pretty quick. Olivia?
The thing that's different about this one, in the factor one, is that you multiply the bottom ones.
Yeah.
But in the factor one, you just multiply the side ones.
You are absolutely correct. The difference between this and the greatest common factors is greatest common factors, you just do the outside, the ones on the outside. But when we do least common multiple, we're also doing the ones on the bottom. Okay. So now let's do it with our 6 and 10. So if my numbers are 6 and 10, what can I pull out? Does it? 2. 6 divided by 2 is 3. 10 divided by 2 is 5. Can I pull anything else out?
No.
So what am I going to multiply together? Fiona? 2 times 3 is 6. 6 times 5 is 30. So when we did it up top by listing out our multiples, we circled that the lowest multiple that they shared was 30. We could do it with our table method without having to list all those multiples out. Claire?
Always have to go down to the right.
Yes. Yep. So when you're using the table method, you always set it up the same way. You always pull out and then go to the right. Any other questions on this method? Henry?
So it's a 3-page.
Oh, nope, I asked if there were any other questions on this method. Damien?
What if the numbers that they're giving you are prime numbers?
These are multiples. So what would we do if we had 3 and 5? Can I pull anything out of it?
No.
No. So remember, we go down and over. If these are my bottom numbers, those are my bottom numbers. I just don't have any on the left to multiply into them. So the least common multiple of 3 and 5 is 15. So if they're primes, and you can't pull any primes out, you just multiply them together. That was a really good question. All right, let's scroll up. Find the least common multiple of each set of numbers using both methods. So for these two, we are going to use both methods, just like with the greatest common factor, just for these two. So let's do 15 and 21. What are my multiples of 15? Wait. Multiples. So 1 times 15 is 15. 2 times 15 is 30. Keep going for me, everyone.
45, 60, 75, 90, 100, 105, 120.
All right, I'm going to stop there. Let's do 21. What are multiples of 21? 21.
128.
What's after 84?
105.
Oh, what did we just notice?
105.
Okay. Matthew, I'm gonna ask that we not be goofy like that, okay? So let's do the table method. So we had 15 and 21. Is there a prime I can pull out of both? Grace?
3.
3. 15 divided by 3 is 5. 21 divided by 3 is 7. Is there another prime I can pull out?
No.
No, so I need to multiply those three together. 3 times 5 times 7. What do I get? 105. So it works to list out your multiples, and we hit 105, and oh, there it is. But just like with greatest common factor, sometimes you can miss one. Sometimes you skip count those multiples wrong. Sometimes we don't know our multiples of 21, because I had to sit and think that one through, because I don't have those memorized. So sometimes it can be a little harder to do it, but do we get the same answer? Yeah. Jude.
And doing the least count, the MCL,
Mhm.
it was easier for that one because the numbers were super hard.
All right, so let's look at our next one. Now we have to do multiples of 9, 15, and 18. So multiples of 9, we know those, right?
Figure out how we got 105.
For which one? James, for the listing the multiples or for the table method?
Table.
So use your calculator. What's 3 times 5 times 7? So that's why we always have our calculator out for math class. And next time, James, just raise your hand and say, Miss Gambino, can you do that again? Okay?
Yep, 105.
Well, I'm letting James have a chance. Thank you, Addie, for confirming it. But so that's how I got it. Because we were using calculators, and we could do 3 times 5 times 7, and it comes up easier with the calculator than having to write it all out. So I did it quickly because most of us had our calculators out. Okay? So calculators are fine unless it's an objective where I say no calculator for this objective. This one, we can use a calculator because your calculator is not going to tell you what the multiples are. You have to know how to find those multiples. So let's list our multiples for 9. Say it out loud for me.
9, 18, 27, 36, 45, 54, 63, 72, 81, 100.
90. We don't want to skip the 90. So I said try going out that 10 and see if you can come to it. So multiples of 15 we have listed over from the other side, so I'm just going to copy those because we already listed a bunch out. Okay, now we want to list out our multiples of 18.
I'm terrible.
I know the first two. I know 18, 36. Oh, say it slowly for me. What was it? 54. 72, you said?
Yep.
90. Ah. So I knew that 54 was here and 54 was here, but there's no 54 for the 15. I have the 72 and the 72, but oh, okay. So 90 is that first one that they all three share.
Why don't we ever do greatest common?
Why don't we ever do what?
Greatest common.
So Lucas has a question for the class. Let's see who knows the answer. Why don't we do greatest common multiple? Dominic? Because it's infinity. Multiples go on forever and ever and ever and ever. You could always keep multiplying up. So we can't say greatest common multiple because you can't find it because numbers go on forever. That's why we say least common multiple, because We want that first multiple that they share. Addie?
So if you were in college and you had asked that question, could you just answer infinity? Because typically it would be infinity.
Sure. I'm not a college professor, so I can say sure. Go ahead. I honestly don't know. That would be a question to ask a college professor. So now we have 9, 15, and 18 with our table method. What prime can I divide out of 9, 15, and 18, Lately? A 3. 9 divided by 3 is 3. 15 divided by 3 is 5. 16 divided by 3 is 6. Is there another multiple that they all share?
No.
What do? I have to multiply all of these numbers together. 3 times 3 times 5 times 6. Use your calculator. What is 3 times? Do you need to do it?
I got 270.
Good.
3 times 5 plus 6 is 9. Yeah, that's not
Here, use my calculator. Maybe it's 2 numbers. Yeah, it is 3. No, that's correct.
270.
Did I do my math right? 15 divided by 3 is 5. 18 divided by...
I got 270.
Here.
Yeah, same. I did 3 times 5 times 6, but I got that and I cleared already. So if you don't use it,
But we had to use it here.
yeah, I know. Yeah.
What the?
I got 800. It's 2.
I got
810.
I don't know how you got 810. 3 times 3 times 5 times 6 is definitely not 800. Okay, friends, have a seat. Give me a moment to look at this, because over on this one, the table method worked just fine. So we had to do the 3. So here's why. Oh, do you know, Fiona? Good guess, but no. Here's why. Notice how 3, 5, and 7, none of them repeat, right? We don't want to repeat any of our numbers. So we already had a 3 in here, we're not going to repeat the 3. So 3 times 5 times 6 is 90. We don't want to repeat any prime that's being shared. So we've already said the 3, we don't want to say it. Is this yours? We don't want to do it again, that's why. Okay? Owen?
Then wouldn't it not be this? Because there were like
That would just be 60.
yeah, it would just be 60. Because there's 2 3s and 2
Lately.
Maybe if you did like 90 plus 90 minus 10, it would be 90.
Where did you get your 10?
Oh, wait.
Did we do our multiples of 8 correctly?
I did that wrong.
18 times, or 9 times 18 times 3.
Good afternoon, students, to your Thursday afternoon announcement. We have a few activities going on after school today. Golf starts after school. There is drama for most of the class and 7th and 8th grade robotics. We have results of our student council.
Okay, I am gonna stop the recording
Our new
and we will
2023,
record,
2024 student
tomorrow.
council.